Hi, today we will demonstrate the capabilities of the Drillsoft PMCD software. Drillsoft PMCD was built on Drillsoft HDX with additional features to simulate pressurized mudcap drilling and floating mudcap drilling operations. These additional features include loss of circulation, total loss of circulation, bullheading, gas migration, fracture severity factor, and also indicating the fracture zones. As you can see in my window, we maintain the same user interface as all other Drillsoft software packages. On the left hand side we have our wellbore schematic. We have 3 loss zones indicated here, and we can also configure our well or change stuff in the project, trajectory formation, tubulars, fluids, and preferences tabs. We can indicate our loss zones under the Trajectory and Formation tab inside of the Lithology Pore and Fracture Pressure box. Here we have 3 zones. Our first zone is at 2,600 feet. We did this by indicating loss here. And we have a second one at 3,200 feet. And then a third one at 4,000 feet. And for fluids, we're using fluid 1, which is 12 pound per gallon oil-based mud. Our light annular mud is an 11 pound per gallon oil-based mud, and seawater is 8.34 pounds per gallon. We can decide what trends we would like to keep track of. For now, we're keeping track of surface back pressure, standpipe pressure, ECD, and equivalent mud weight. These are the default trends that are pre-configured. You can also track flow reversed, the amount of the rate we're bullheading at, and we can also activate pore and fracture pressure gradient patterns so that we can have a better observation of what's going on in the well. So let's activate those. Now we can see our pore and fracture pressure window and the gradient window. And we have our trends here. To use the PMCD options, we'd have to go to the sidebar. We can open this by clicking the gray area here. And under the correction factors, we can go to PMCD. In PMCD, we have the option to choose what fluid we want to bullhead. We have the fracture severity factor, which determines how much pressure is needed to go into total losses in the formation or in a fracture zone. We can choose floating mudcap drilling, which would, for now, is disabled, which would put our operation into a floating mudcap case where we would have no returns at all and a lower mud level in the riser. We can allow for flow out control, so if we want to pump mud into the well, or control the rate, we'd have to choose this. And we can also allow gas migration in case there is gas inside of the formation that we have fractures at. We can change the migration rate and the gas concentration. These are 1,000 foot per hour and 7% by default. These can be updated based on how fast the surface back pressure is rising during a PMCD operation. This mirror gas rise velocity allows us to determine what rate we need to bullhead at to overcome the gas migration rate. This will plot a negative value, a negative mirror image of the migration rate. These 2 boxes here, the first one is the top of the gas, which will tell us the location of the top of the gas. And the total reverse volume will tell us how much mud in total we have bullheaded into the well. So in order to start any simulation, we have to start with entering a flow rate. For this case, we'll use 300 gallons per minute, and we'll hit play. So now we've begun circulating mud at 300 gallons per minute. We can indicate surface back pressure. So for this case, let's start with 200. And as soon as we enter this, our flow out begin to drop because we are losing. As you can see, the 2 zones are losing mud at the moment. We can keep increasing this until we get to total loss of control. Now we still have 2 zones, and this is also plotted here. And since we had gas migration, we allowed that. We had gas coming up, but for now let's deactivate that. Let's go up to 280. And now we have complete loss of circulation, total loss of circulation. We're not receiving any returns. Instead, we are pumping mud into the annulus at 150 gallons per minute. So let's begin pumping seawater through the drill pipe so that we're only losing sacrificial fluid rather than losing our expensive mud. And since we're bullheading, we may as well change that to light annular mud. So we begin pumping in seawater through the drill string and lam in the annulus. And we'll keep track of everything that's going on in the well. Our flow out has reduced to 125 gallons per minute. Let's keep going down. We have the seawater returning. We can keep track of all of our fluids. We can see that our expensive mud, we're losing it to formation now. We're losing mud on all 3 zones. Can also activate gas migration and flow control. So let's go ahead and increase the rate to 300 gallons per minute. So we're bullheading at 300 gallons per minute. We can see how that is affecting total reverse volume. Now that we're letting gas into the well, we need to keep track of what's going on here. So by activating mirror rise image, we'll get a similar line to this one, but in the negative value. And that is also plotted here. So as long as the angular velocity is to the left of this line, we are bullheading gas back down to the formation, to the fracture. So you can see above the 3,900 feet, or the third fracture zone, the deepest fracture zone, our angular velocity is negative. That is because our mud is moving downward in the annulus into the fracture. And below the fracture, we have mud angular velocity at a positive value because the mud is moving up towards the fracture. And as you can see, the surface back pressure, standpipe pressure are about changing very, very slowly. We can also look at trends. Keep track of the surface back pressure, which is rising. So we can stop pumping in mud. See what happens if we stop pumping mud in. In this case, we have wellhead pressure still going up, and we can also see that the top of the gas has moved up. And it's continuing to move up. The gas in the well is also indicated by a yellow highlight here on the left side of the graph. You can see that in pressure, ECD, temperature, and hole cleaning graphs. And we can continue bullheading. We can speed up our simulation by sliding this bar up. And slow it down, we can pull this back down. Okay, and at this point we have none of the original mud in the well. We only have our seawater and our lamb. And the gas is staying constant at 2,600 feet, so we can stop circulating, and we can stop bullheading. And we can even increase this value 100, or let's just keep it at 300 gallons per minute. And let's begin rotating drill pipe and start drilling at 100 foot per hour. So now we're drilling the well. We're pumping seawater at 300 gallons per minute, and we're monitoring the surface back pressure. We want to prevent the gas from entering the riser, so we'll monitor where the gas is. We'll allow it to rise until the surface back pressure reaches a certain threshold. For this case, we can say 620 psi or 630 psi. You can also monitor this in the trends. You can speed up the simulation. And now we're drilling our well. You can see where the gas is. And in total we've bullheaded 566.5 barrels of lamb. Plus we also did, at the initial part, we also bullheaded some drilling mud to keep the hole full. But now we're only going to use lamb for bullheading and seawater to pump through the drill pipe. Our surface back pressure has reached 627 psi, so I guess we can start bullheading again. And let's see what this does. We'll immediately see that the surface back pressure went down. Let's go to hole cleaning, see if this is enough pressure to push the gas back down, and as you can see, it is. As long as our angular velocity is to the negative, is to the left of the mirror gas rise velocity, we should be good. Since the gas reached 2,600 feet, let's stop bullheading. Let's start drilling again. As soon as this reaches 630 psi, we can stop drilling again and begin bullheading. So the surface back pressure is almost at 630 psi. So when this happens, we can go ahead and stop drilling and begin bullheading. So this immediately pushes the gas back down. You track where the gas is here, and the surface back pressure also goes down. So it's no longer changing. It's stopped at 490. That means the gas is no longer migrating. It's no longer moving above the top fracture. We can go ahead and stop, go out, and begin drilling the well again. Change the color. We can also see the volumes, the ECD, temperature, the pressures inside of the well. This is a good way to diagnose any problem. It clearly demonstrates what the pressure is for each section of the well. We can print this in a report. Let's also change the color for flow reversed. Let's do. It's easier to see. This time we're waiting until surface back pressure reaches 650 psi. Can speed this up even more. So we're at about 650 psi. You can see where the gas is here. We can stop drilling and begin preparing for another cycle of bullheading. So now we begin bullheading the gas back down into formation. You can see how rapidly gas is moving. The pressure is also dropping. You can see this in trend. The pressure should drop somewhere around here. And the pressure is no longer changing. It's stopped at 490. So let's go ahead and stop bullheading, and let's start drilling again. Can monitor. Save mud. Let's do shorter cycles. So we're at 1,418 barrels mud so far bullheaded. So let's try and bullhead less mud. For that case, we can start bullheading again at 650 psi, 615 psi. As soon as this reaches a stable value, which is 490.91, go ahead and indicate 0 here, and continue drilling again. Slow the simulation down, get better control. The surface back pressure is a good indicator of where the gas is inside of the well and how fast it's migrating. We can go back on our data and see what happened in the past. We can zoom into a certain point or section. We can prepare to bullhead again. As soon as we reach that stable value again on surface back pressure, we can stop bullheading and begin drilling again. We can continue these cycles and completely drill the well. All the data can be printed by hitting the text button here, and the data will be exported into a text file for all of these trends. We have 9 hours and 31 minutes worth of data. It's being exported into a textbook, into text format. The exported text file is as you can see, it contains all the trends we activated. If we activate additional trends, it will also track those as well. We can also print our reports for all of our simulations here. Get our hydraulics report. So we have our volumes, ECDs, pressures, densities, and also the hydraulics inside of our drill string in the annular space. We can export this into Excel, PDF, or Word. So this is how you use Drillsoft PMCD. This is useful to simulate a PMCD operation or plan it. It will help with these cycles. If you have any additional questions or comments, please contact us at www.drillsoft.com or follow us on LinkedIn and Facebook and other social media places, and please share this video. Thank you.